Welcome back to the channel. Unless you're new, then welcome. So last week our app finally launched on App Store, the Google Play Store, and we received a lot of views on our channel and we got a lot of downloads as well. So I thought that it would be a great time to go through our dev journey and how we came up with the idea and the process that we went through to build the app. So we started with our startup in August of last year, and basically when we started out, we went through a lot of ideas of which products we could build and which services we could offer to people. The very first one was a trading dashboard, and that was a very basic concept that I built myself, but I didn't see a lot of scope. So then I moved on to exploring home servers and how I could then deploy my services that other people could make use of inside my home network, and that gave rise to Infra Edge, the Proxmox services that we offered, the cloud services. And I'm going to be very honest, that didn't work out as well. It could be labeled as a failure. We received around 4 customer requests in total, but for the free trial, none of them then converted to actual uh, buys. And once that was over around March or around Feb and March, we went through some ideas, but none of them were good enough to pursue. I even went so far as to consider building a product or an app using Blender to make use of AI to assist with the creation of all the renderings, but that was not a good idea. So I went through a lot of thinking, but I couldn't find any ideas worth building. So I was almost on the verge of quitting, but finally I came across a really good video by a YouTuber named Daniel Burke. He's based in Australia, and he is a really good ML teacher, but he also has his own app called Nutrify. So Nutrify is a food recognition app which is designed by Daniel Burke and his brother to to make the users learn more things about foods, whether it's nutrition or the number of calories or micronutrients that they have. But the app is limited in the sense that currently I think it recognizes more than 500 foods, but it is available only on Apple. It is not useful. It cannot be used by people who use Android phones. So that's a serious limitation. And going through his videos, they were a lot of inspiration. So Daniel, if you're watching this, thanks a lot, because your videos are a great source of inspiration to me, especially when it comes to learning more about machine learning concepts. And since last year, I've been exploring a lot of things in image recognition and computer vision. And I found that to be a very interesting field which I wanted to explore for many more years to come. And since I was already interested in this, and I saw that Daniel had built this Nutrify app which could be used to recognize foods using nothing but your phone camera. Obviously, that kind of was an idea that immediately resonated with me. So I wanted to explore more in this. And looking back, I think it was my best decision, because immediately I fell in love with the concept that you could just use a mobile app to take photos of your food, and immediately a machine learning model that runs on your device or on cloud will instantly let you know everything about the contents of that food, such as the micronutrients or the amount of calories that it has. So I was inspired to build such an app on my own. I went through many other existing competitors in this field, and I quickly came to realize that I wanted to be a part of this field of this food industry or healthcare, or more like a fitness app kind of industry. And I think it's a pretty big industry, like worldwide it could even be a billion dollar industry. So once I realized that I wanted to make an app similar like Nutrify, I then set out to find how can I differentiate from Nutrify. So one of the things is that Nutrify focuses on whole foods rather than on barcodes. So you cannot scan a barcode for the food that you buy, so that's obviously a differentiator. Then there's the fact that it only caters to iOS people. So there are a lot of people, mostly I think 90% of people in India use Android, so that's a clear differentiator. I could build my app and grow it in India. And basically Nutrify is meant to be a kind of an educational experience even for kids who want to learn more about foods. But I wanted my app to be perfectly tailored for bodybuilders or people who are very serious, who take fitness very seriously. So my initial hypothesis was that instead of people needing a weighing scale to measure their food every time, because you cannot carry a weighing scale around with you outside, only if you're inside your home you can use that weighing scale to measure your food weight and then do the mental arithmetic in your head to calculate the macronutrients or the calories. Every time you would have to do a Google search for the food that you're eating and then do that calculation manually. But I wanted to know if there is a way that you could just take a photo of your food and the AI model could then automatically tell you the depth of the food. It could then estimate the volume of the food, and then based on that the calories or the micronutrients of the food that it recognizes. So there's a really good data set by Google called Nutrition 5K, and initially I went out exploring that data set. It's a very complicated data set with many complicated things. Like, first of all, very luckily I found that another guy had made a distilled version of the Nutrition 5K dataset where the images were much clearer and much better labeled. So I went with that dataset, and I quickly found out that if you train a machine learning model for regression to calculate the weight of the food just based on the photo of the food that you take, it is not very accurate, which is to be expected because no AI can just calculate the food weight based on the photo. It cannot, doesn't have sensors deep enough to measure the weight of the food exactly. It's just, I think we are way behind on the AI journey, that this stuff cannot just be achieved right now, and any fitness app that claims to do so is clearly a scam. So the learning model which I first trained, the very first one for regression for the calculating the weight of the food, was slightly accurate when it came to calories, proteins and fats, but it was way inaccurate when estimating the carbs of the food, whose photo we are sending it to. So that was a failure, but I think in future I could explore this stuff again, the caloric estimation based on the food, but right now that's just not possible. So for this caloric estimation model, the depth estimation model, my first goal was to train a mask RCNN model, to know whether it's possible to train nutrition 5K dataset on it and see if that's possible. But it's not it's not practical, it's not production ready, and I think it needs more time or more progress in the field before that kind of approach is possible. So basically, I wanted this model to infer the depth and size of the food portion, or the food portion size, based on visual cues like the texture or the kind of the overall depth which we could see from the photo, even if we take that photo at a 3D angle instead of a 2D angle, or segment it, kind of like segmentation filtering. But it's a very tricky process and it's just not possible. Like I mentioned, that model was accurate, slightly accurate for calories estimation, regression estimation of nutrients like proteins and fats, but it was way inaccurate for carbs. So we left that idea for now. Maybe in future I could explore it more. And before I started out with my app building process, I wanted to make sure that my idea is completely has complete scope for growth. So I didn't want to explore a completely radical new idea with no proven user base. I wanted something which has a proven track record of success. So instead of just copying another competitor in this market, I wanted to make sure that I have a clear differentiator and I have a clear advantage over them. So I will be talking more about this later, but right now I have these notes which I wrote before I started my building process, and this is something which I always do. uh, Anytime I want to go through a project which I am building myself, I first write down everything, all my ideas in this, so that I get a clear sense of direction. So here we go. BulkBites launch product in 2-3 months. So I give myself a deadline like for this, but the deadline was April 15th for the first MVP, the minimum viable product. And I've written this. So Nutrify only for iPhones, it's a limitation. Then there are other apps like MyFitnessPal or CalAI. MyFitnessPal has the largest user base ever, like in millions. They generate millions in revenue, and they are the number one in this industry. So I think in future, if I could be on par or cross them, then that would be a really good milestone for me. Then I would be satisfied with my progress. So CalAI, it has no free trials. Maybe it has a free trial of 1 day, but then they charge here in India like 990 rupees per month. And so in this app, the concept which I had, I didn't want to just include the things which are found in these apps which I mentioned, like food recognition and then knowing all the calories and etc. But I wanted it to be a multi-feature app, not too many features so as to confuse the user. It should be simple and intuitive to use always. But other features such as meal prep, meal planning, or recipe assistant, like based on the foods which we have at our house, could we combine them to make a new food which we do not know beforehand? Maybe the app could suggest things like that. And another feature where instead of just something based on food, we could then turn it into fitness, like workout assistant. The You could just put a camera and then record yourself having a workout, like doing bicep curls, and then the app will like notice your movements and then movements of your joints and everything, and then tell you whether you're maintaining correct posture, correct form, or whether you should have improvements. You should lower the weight, you should increase the weight, you should do it in a slow tempo, length and partial, everything, all that scientific thing. But basically a simple workout assistant. And for this last feature, we need something more than a basic ML model which we can train. We actually need to make use of APIs to chatbots which are deployed somewhere else in the cloud. So this is a very complex concept which we can explore later on. But I think there was an app called Larry AI associated with Larry Wheels, which had a concept like this. So that was the concept which I had running in my mind when I wrote all these notes. But let's see. Right now, I don't know if I have any plans to go through with them. But who knows? Maybe in future we could do something like that. So I wrote that some AI apps like CalAI or other apps, we don't know for sure what do they use in their backend. Maybe they could use a depth estimator technology for calorie tracking of food via images. I wrote here that train a model to recognize food depth, size, nutrition estimate, and food weight for portions. So we don't need weighing scales anymore, but that's just not possible, at least for now. Then analyze work of videos, suggest form improvements, how to adjust diet based on goals, your fitness goals, whether you want to gain weight, maintain weight, main gain, or lose weight, cut. And users can upload physics photos and videos regularly to track changes and get personalized insights, make diet changes, update plans, and more. And I was never a fan of mobile apps. Like I never touched anything related to mobile apps, Android or anything. So in my mind, I had envisioned a web app. So web app accessible across all devices. But after a few weeks, I found that it's a very stupid move. You could just build a mobile app. So that's what I finally went with. And so these are the notes which I wrote later on. Dominate this market. Keep on innovating in AI with this, like edge AI or VLMs, that's vision language models, then object detection, app features, etc. Features for first MVP, food recognition and calorie plus macronutrient estimation, carbs not included. So I then discarded that. Second MVP should have a recipe assistant, better model accuracy. Third MVP, gym videos, physic images that feature. Options, food, cook. Like I went through datasets like food AI datasets, recipe from images, then gym, physic. Okay, so these are random things which I wrote. Backend step one, food presence detection. I should use a binary classifier for that, maybe uh, to classify whether it's a food or non-food, because we are building a food app. So if you take a photo of a non-food object and it tells you something that it is a food, then clearly that app is a failure. So first, the very first model which acts as a gatekeeper should tell whether it's a food or a non-food. So that's a basic requirement. Then step 2, food classification, food 101 dataset and single food items. So I'll go through this later. And step 3, macronutrient caloric estimation, that's the nutrition 5K dataset. So when I started out, even before building the app UI or knowing anything about React, because that's the language which we wrote the app in, React Native, I went through training the models first to understand exactly the whole process. And thanks to Daniel Burke again from Nutrify, based on his inspiration, I got to know how the data flywheel approach works. Like you take in the data in the images, you maybe annotate them manually if in case you have manual images, manually taken and collected those images. You then label them using something like Label Studio. Then you train the model, then you monitor the model performance and the growth or track improvements using something like weights and biases. And then based on that, you then keep on iterating and iterating till your data and your model improves at the same time. So that is something which he himself got inspiration from Tesla, because Tesla uses such data flywheel to train their self-driving car technology. So then the first experiment which I ran was a nutrition 5K dataset for that calorie estimation. And very luckily I found a filtered dataset of around 6 GB provided by a guy named David Blainer. So for this first experiment, I went with an efficient V2B0 model from PyTorch, and this was for regression estimation because I wanted to explore whether it's possible to do so. And this is for calories, fats, proteins, and carbs. And I'll go through some of the actual dev process, but for those who are not interested into learning more about programming, you can just skip a few seconds forward. To normalize these four categories to allow for food training, uh, basically I had to normalize them using log values, because the calorie values were in kilocalories, the unit kilocalories, and these values were very far big skewed away from the small values of proteins, carbs, and fats for each food item. And that was causing the loss curves to uh, fluctuate a lot during training. So they were a lot biased towards calories, and in turn a lot inaccurate for calories as compared to these three small values: proteins, carbs, and fats. So I had to normalize them using the log function, and using the log function then scaled them at the same level. And then I got a steady loss curve. And for only for 10 epochs the loss was very low, and as I mentioned, the calories, proteins and fats had slightly good results, but for carbs it was way inaccurate. So, and that's something that can never be accurate, because no matter how good you train a model, for every kind of new image which you take in the real world, it will always give a false estimation. So then the experiment two was I moved on to food classification. So I wanted to see for my first app MVP how many food items I could include in this, because I knew that Nutrify currently has 500 and more than 500 food items which it can accurately identify with good confidence and everything. So for food classification, I went through many data sets, and basically I adopted my own technique. So first I took a model just like efficient net model from PyTorch. I use PyTorch for all my training, and that also has a limitation which I will explore later on. But I went on where I took some data set like food 101 data set. I'm comfortable telling you guys which datasets or which model I used, because in the end, I know everything about how I built my app. So I am confident that even if someone copies or rips off my idea, they cannot go on very far, because in the end, I am a very competitive person, and I intend to stay in this market for a long time. So food 101 data set I tried. So it has 100,000 images total and 101 classes of food items, and these food items are mostly non-Indian. So they come from Mediterranean, Middle Eastern, European, those kind of dishes. And that was something which I didn't like, because I wanted my app to have Indian foods the most. So yeah, even then I then trained that data set, used that data set for training my model, and I got a pretty good accuracy on that. And basically first I used Google Colab, but I found that it had some serious limitations. I then explored many other GPU, these websites that offer free GPU instances or notebooks, but none of them come as close as Kaggle. Kaggle is, in my opinion, the best place to train your machine learning models, especially for image processing, because Kaggle notebooks provide two free GPU uh, per week. So each week you have access to around 30 hours of free GPUs, two GPUs, which you can use parallelly. And that's a very good benefit over Colab notebooks. And you can even easily join the Kaggle datasets into your notebook and then use them to train your models. And you can even save those models and very easily, and then you can even download that models easily. So that's a huge plus point. That was a huge plus point for me. And once So the first dataset was the ETHZ Food 101 dataset, and after training that on the model, I then found out that I wanted the model to identify more foods. So what to do now? Because once you train a model, you then have to retrain it again from the very beginning on a new data set. But how to combine one data set with another, because combining two data sets with different annotation values or different rows and columns, it's just very confusing, even if you are using a library like pandas. So there's a concept in machine learning called uh, fine tuning or freezing layers, and there is an even another concept called catastrophic forgetting, which I'll explore in a bit. But basically fine tuning allows you to take a pre-trained model, or in my case the model which I just trained right now on that food 101 dataset. I can take that dataset and freeze some layers of it, freeze those parameters, and then take the new dataset, filter So the new dataset which I took was something like for 265 classes, and basically some classes were common with the 101 classes, so I had to remove those classes and filter out the remaining ones and then join them together for the new images. And this filtering process was very easy, like I had to make some adjustments here and there, and then I can take my this newly trained checkpointed model and I can train it on this new filtered data set kind of structure. So basically it is now trained on the original 101 classes plus these new classes as well, and that came to around 256 classes in total. So that was the huge plus point for me, and I could just then experiment with gradually unfreezing layers after the third epoch and so on to achieve the perfect accuracy which I then got for my current model. And this is currently the food classification model which we use for our BulkBites app now. So for the first model, the very first model, the Food 101 class model, it was kind of accurate. It had a good accuracy and a good loss curve and everything. But when I tested actually on images like chicken breast pieces or ice cream or omelette, it was slightly inaccurate in the sense that it told me that my ice cream is a frozen yogurt and so on. So once I took that model and then retrained it on this bigger data set, the filtered one, and went through the gradual unfreezing pipeline, then I got a really, really good model, and that model was outperformed everything, like when it came to ice cream, omelette, and all other food classes. And so now the last thing that was remaining was using a gatekeeper before I could use my food classification model. The gatekeeper could tell me whether the image I have taken is of a food item or a non-food item. And I went with binary classification. I searched for many data sets. I got some data sets for it, but those data sets were very small and not suited for my purpose. They gave very bad results. So in the end, luckily, very luckily, I found a data set on Kaggle, but it was not for binary classification. It was modified to cater to YOLO models, and YOLO models are object detection models. And we don't need object detection to find whether it's a food or a not food. You could just take the whole image and do so. But that was my initial thought. But later on, I found that this is a very good advantage. YOLO is much better. I then trained a YOLO model on that data set, but after training I found out that you cannot deploy a YOLO model locally on your phone, because remember, for my app like Nutrify, I wanted to deploy these two ML models in the backend on the user's device, so the app could fastly run inference on the taken image and quickly give the results to the user. That's the idea that I had in my mind, that I wanted to make it fully local, fully everything, even offline it could work perfectly. But it's a very, very difficult hurdle. This area of edge ML, or the area where people deploy models locally, it's very tricky and very difficult. And after many days of frustration, I just gave up on it, and then I finally decided to deploy my models on a cloud. So the reason is that if you train your models in PyTorch, you cannot deploy those models locally on a mobile phone, because PyTorch provides no such library to do so, no such framework. There are some frameworks like Executorch or Py. I even forgot the name because it's that insignificant. But basically, it's very difficult, and you can only use TensorFlow models locally. TensorFlow has their own framework, TF Lite, but so now I was accustomed with PyTorch and I had trained my model. I had spent hours training that model and everything. and I didn't want to go through that whole process from scratch again to just to make a TensorFlow model. So I went through a very tedious process of converting my PyTorch models to ONNX format, and then to some other format which could be ran on a mobile device. But in the end, I just gave up on it and said that let it be. I don't want to go through with this local running. I can just deploy my models on the cloud for free, and that's what I finally chose to do. And so now, before I was very frustrated and depressed that I could not use my YOLO model for object detection locally, but in the end I can just deploy my YOLO model on cloud, and that works perfectly. So now when a user uses our app BulkBites to take a photo of a food, first that photo is sent to our cloud, and then the photo first goes through a gatekeeper model, the first model that is trained on the YOLO dataset, and then only if it classifies the food as only if it detects the foods as a food item. So basically, for all the detections that the model detects, it then clubs that, and if that average exceeds a certain threshold which I set myself, then only that model goes to the other second model for food classification. And once that food is classified correctly, confidence is printed, the top three predictions are printed, and then those that a result is verified with an SQLite database that contains all the information about the food, the information which we collected going through many databases hosted online to make our own nutrition engine. And once that is achieved, we then send that result back to the app, and the user gets the whole result in front of him. So this is kind of the rough workflow that I went through to build my first MVP of the app, and it has given really good results, really great results. The models which I trained far exceeded my expectations, even if the final result is 256 classes, which it can correctly predict. I am very confident that we can grow that to much bigger classification results once we get to train our models on more and more data sets as time goes on, and as our users give us more and more updates. Once we launched the app, we received very good response on all our social media handles. Right now our download count is around 25. Once the ML model training process was done, next I went through the app building process itself, the mobile app, and very unfortunately, I chose Flutter as my first choice. And after many hours of frustration, I quit with Flutter. It's very complex. I will not touch it with a 10-foot pole in future ever. And then I finally settled with React Native, and React Native is kind of good. I like it. Like it's very easy to understand JavaScript, and it's very easy to build for Android as well. And that's the approach that we finally went with. So I'm glad that it turned out this way. The main thing that we found out during building was that we referred to a couple of research papers, and one of them had conducted a survey on many people and found out that mostly people uh, find it very boring to manually log what they have eaten every day. They find it cumbersome, and they find it they just would rather not keep a record of everything at all. They find it time consuming, and it's just a kind of a cognitive overload to them. So any kind of app which could magically uh, allow you to snap a photo of your meal, and you can accurately get the result, and it automatically logs in to your history. That app would have a clear advantage in this market, and that's what we are aiming to do so with under our BulkBites app. Basically, the research paper which I refer to is called the FoodX 251, and they say that the food journaling app space has some competitors, but none of them come close to the potential they could achieve. So the technology is there. The only thing left is the user onboarding process in this market. This market is ever growing at a steady pace. It is set to do so forever. Never would it come down or create loss for the competitors. So basically, our goal is to be the best for journaling app of all time, the world's best calorie tracker app of all time, and an app that makes ultra accurate predictions and does not make false claims about knowing the weight of the food or anything, because our app is said to be an calorie estimator based on per 100 gram of the food, whatever it is classifying it as. And there's a lot of scope for research and development in this field, and that's what makes me very excited about it, and I'm very confident that I will be continuing building this app for a very long time. So for our next app update, which will be coming before July beginning, it will have many new features such as a recipe assistant and meal prep plan for millions of recipes, along with many improvements in the model itself, like it can now recognize Indian foods correctly, and if it incorrectly assumes something, you can just use a search bar which you have added to manually log the food yourself, or to add the weight of the food according to your estimate, and many other changes to the UI as well. So we are very confident that the next release would be a huge success. So enough talk for now. Go to the Play Store, download our app right now. BulkBites Ultra Accurate Calorie Tracker.